Good afternoon, my grade 11 students. Welcome to the chapter review for chapter 4, Trigonometry. We're going to be taking a look at the chapter review at the end of chapter 4 in the textbook that was assigned today to get you ready for the test tomorrow. So here is 4.1, special angles. And our first question is asking us to use the unit circle to determine exact values for the primary trigonometric ratios for 210 degrees. And I think it's awkward to use the unit circle. I think it's much easier just to think about this as an angle in the xy plane and then to draw your special triangles. So that's what I'll show you here. So what I'm going to do is I'm going to sketch my axes. So here is the x-axis, here is the y-axis, and here is an angle 210 degrees. 210 degrees is going to go around past the x-axis by 30 degrees. It's going to go right there. And that's my angle 210. Let's draw that out a little bit and then go up. Ooh, what an ugly triangle. Here we are in the realm of ugly triangles. If this is a 30-degree triangle, then I know some things about this triangle already. I know that if this is height 1, then this would be radius 2, and then this side would be root 3. That's my 30-degree triangle here. Now this one here, is actually a negative one. Why? Because it's going down below the x-axis, so that's negative 1 in the y. I can also use my cast rule, C-A-S-T, to think about this angle, 210 degrees. And this tells me that tangent is going to be the only trigonometric ratio that's positive, and the cotangent as well. So I've been asked to find the primary trigonometric ratios. Okay, sure. So I don't need cosecant, secant, and cotangent in this case. So what is the sine? Well, sine for this, sine 210 is equal to, well, it's going to be the same thing as sine 30, except it's negative because sine is negative over here. It's also opposite over hypotenuse, so this is negative 1/2. Test that on your calculator, you'll find it's true. Cosine 210 is equal to the adjacent over the hypotenuse, so root 3 over 2. But this root 3, it's also negative because that's negative in the x-axis. So that's a negative value as well. And then the last one, tangent 210. Now I could write it as opposite over adjacent, negative 1 over negative 3. Root of negative 3. Oh, sorry, that's also not right. Negative 1 over negative root 3. But why would I do that? Why wouldn't I just write it as positive? Because the cast rule tells me that this angle has a positive tangent. So that's 1 over root 3. There we go. So that's question number 1 answered. Now question number 2 asks us to set up a question where a ship is tied to a dock with a rope of length 10 meters. Okay, so draw it. So we're going to create a picture of this, and we'll do it down here. Here is my boat. Clearly, that's a boat. You can make a boat with a half circle, stick, and a triangle, if you didn't know that already. Or you can use more fancy shapes if you're actually have some artistic talent. And we have a rope length at 10 meters. The rope is stretched tight, forming an angle of 45 degrees with the horizontal at low tide, okay? So this is my low tide boat. This is angle 45 degrees. And this is a 10 meters, all right? And then at high tide, the stretched rope makes an angle of 30 degrees. Okay, so I could do that in another color here. Pion, I'm going to have to go through my 45 there, but that's 30 degrees. All right, and that's also 10. Now, what I would like to do is draw 2, and I can sort of use that to imagine that this boat is further away when the rope is flat like that. So I want to know how much closer to the dock horizontally is the ship at low tide than at high tide. Determine an exact expression, then use in a calculator to determine an appropriate answer. Okay, so here is the first triangle. This is low tide, and it's a 45-degree triangle. That's a special triangle. 45 degrees. This is root 2. This is 1 and 1. Okay? But this is actually 10 meters. All right, we're going to remember that for later. And then when it's stretched out like this, the 30-degree angle, 30 degrees. This is still 10, but this is now sort of the ratio 2, 1, and root 3. Okay, but that's still 10 meters. All right, it's the same rope in both cases, so I need to scale this triangle up so that it's 10 meters. So how will I scale that up? I want root 2 to become 10. Here I just need to increase the size of this triangle by 5. So let's scale these triangles up so that they're the same length hypotenuse. If I increase all these by 5, this would be 10, 5, and 5 root 3. Okay, and if I scale this one up to 10, well, if I multiply everything by root 2, and then I multiply everything by 5, that will do it. Okay, how do I know that? Because this is root 2. If I multiply that by root 2, it will be 2. Then I have to multiply it by another 5. So that's how I know that this will be 10, and this side will be 5 root 2, and this side will be 5 root 2. Check it yourself. 5 root 2 squared plus 5 root 2 squared should be 100, because that's 10 squared. So try it. 5 times the square root of 2 equals 7.07. Now I'm going to square that. Where's my square button? I should just find one calculator that I like, and that's 50. That's the square root of 50 is 5 root 2. I could also show that with radicals. So yes, that is indeed the size of this triangle down here. So the way I would solve this is I would say this triangle, this is closer to the dock, this is further away from the dock. Why? Because 5 root 2 is smaller than 5 root 3. So the exact expression for the distance between the dock and how much it changes would be 5 root 3 minus 5 root 2. That's how much farther away from the dock this boat gets. And another thing I could do is I could factor out the 5, of course. It's 5 times root 3 minus root 2. And that's about the nicest way to write this. And that I can calculate on the calculator. So let's do that. We want to guess as well. We're imagining this rope 10 meters, and it gets a little bit further away. I'm going to guess that this is like a little less than 2 meters. So I try 5 times, and then I put in brackets the square root of 3 minus the square root of 2, end bracket, equals 1.58, so 1.6 meters. Oh yeah, a little less than 2 meters. So that's equal to, and we can put an approximately equal to 1.6 meters. Therefore, put your therefore over here. Therefore, the boat is 1.6 meters further away, further from the dock, at high tide. And you could also determine from this the amount that the height of the water changes as well from high tide to low tide. Some other interesting properties of that. Now let's take a look at coterminal and related angles. We're not going to do all of these examples here because there's a lot in your calculator, but we're going to take a look at some of them. And I know these types of questions are ones that are confusing some of you, which is normal. We're moving quickly through this material. So let's see if we can get it now. A point now can also be telling us an angle relative to the origin. That's one of the things that we're doing now with trigonometry. So here is my xy axis. And then I'm going to graph this point. We could do 5, negative 12. Sure, let's do 5, negative 12. It has a nice, actually, no, let's do one that does not have a nice square rootable radius, so that you'll see one with a radical in it. Let's do f, negative 7, 4. So here is negative 7, 4. Okay, there's the point negative 7, 4. Guess what it is? I would guess that this is an angle like 135 or so, looks like. An angle from the x-axis, so it's going to be coming over here. And we're saying, what's this angle here? And this is the point negative 7, 4. And now we want to know information about this angle. Determine the exact trigonometric ratios for the angle theta. Okay, so this is angle theta. created by this terminal arm here. So one thing that we want to know is what's the radius? What is the distance from this point to the origin? Because we're going to need that for sine and cosine. And we are only looking at primary trigonometric ratios here. So we don't need cosecant and secant and all those. Let's go narrow here. There we go. So I know that r squared will be equal to 4 squared plus negative 7 squared. The negative comes along for the square root ride, so it's going to disappear. 16 plus 49, and that's going to give me 65. So that's r squared. R would then be equal to plus or minus the square root of 65. But because this is a distance, we only want the positive one, so it's r is root 65. So I can label that as well. I put that on my diagram here, root 65. Beautiful. Now, oh dear. Now, I can build my trigonometric ratios. Just draw the triangle on if you like. And here, this is negative 7, this is 4, and this is positive root 65. So sine, which is SOH, sine theta, is opposite over hypotenuse. Here's the opposite. So this is 4 over root 65. And because of my cast rule, CAST, I know that sine is positive, so I shouldn't be surprised there. Cosine theta is equal to negative 7 over root 65. No problem. That's negative, should be, because it's not in the positive area for cosine over here. And then tangent, this is the only one that we don't need, this root 65. It's 4 over negative 7, but write it this way is much nicer. Good. So that answers the question there. One of the primary trigonometric. Oh, and I'm curious. I want to know how my guess is. So I'm going to use inverse sine of 4 over root 60. Oh, let's do cosine actually, because that one I won't need to use a related acute angle to find this. Second one, inverse cosine of bracket negative 7 divided by the square root of 65. End bracket equals 150. Did I say 135? That was really wrong. It was really, really wrong. 150. I'm surprised. Why did I say 35? That's very strange. I took away way too much. My guess was really off. Okay, cool. I'm learning from my bad guess. So now, one of the primary trigonometric ratios for an angle is given, as well as the quadrant that the terminal arm lies in. Determine the other two primary trigonometric ratios. Okay, well, that's all the information that we need to do that. So let's go for it. We're going to take, let's do tan C. Tan C is negative 12 over 5, and it's in the second quadrant. Okay, so if that's in the second quadrant, then this one actually is nice. This one doesn't have a square rooty type thing on the bottom there. So this one, negative 12 over 5. So that's opposite over adjacent. It's in the second quadrant. And because it's in the second quadrant, the adjacent is negative. So it's going to be negative 5 and 12. So that's the point like up here. That's the point, negative 5, 12. How did I know that from this? Well, it tells me which quadrant it's in, and it tells me its tangent, negative 12 over 5. That's opposite over adjacent, and here's the triangle. Okay. This one we can draw on nice in a solid line. And so that's negative 5, 12. So it's opposite over adjacent. This is the negative. This is 12, and this is negative 5. So that will have that tangent, okay? Boop, like that. And we were asked to determine the other two primary trigonometric ratios. Well, we can do that from this. Let's find the radius here, and I'm going to just bear with me. I'll do it. R squared is equal to 12 squared plus negative 5 squared. So r is obviously 13. If it's not obvious to you, here I'll show you. R squared is equal to 144 plus 25 is equal to 169. The square root of 169, r is equal to 13. Okay, so that one has an integer radius, so that's 13 there. And we're going to need that to find the other two primary trigonometric ratios. Sine theta is equal to 12 over 13, so it's very close to 1 for that angle, and it's positive. cosine of theta is positive because of cast rule. And it's also positive because y is positive. Okay, cosine theta is negative 5 over 13 because x is negative and cosine is positive over here. Okay, so that's sine cosine for that angle. And that was all we were asked to do. But let's also review our inverse trigonometric ratios. The cosecant of theta would be equal to 13 over 12. You just invert the sign to get the cosecant. And the secant of theta would be equal to negative 13 over 5. Just flip it and write the negative on top. Okay, and then the cotan of theta would be negative 5 over 12. There, because tangent was given as that, and I just flipped that. There you go. So that's how you do those types of questions. So now solve the equation. Sine theta equals negative a quarter for it's between 0 and that. Okay, round your answers in questions 5 to the nearest degree. Okay, so then we have cos theta is 4 over 5, and tan theta is 5 over 8. Okay, and these inequalities here, 0 is less than or equal to theta is less than or equal to 360, means find me all the values of theta within one turn around the x-axis. Okay, so that's what you're being asked to find in there. So let's take a look at the first one. It looks like the most challenging one to me, actually, by a long way. So let's take a look at 5a, and we'll see how to solve this type of problem. So if I know that sine theta is equal to negative 0.25, that means I could also write that as negative 1 over 4. Okay, and I would naturally want to write that as a fraction because these are ratios, and I can imagine them much easier if I write them as ratios. Then I can even draw that as a point. Okay, so there's two places where we're going to have a sign that's negative, and they're both down here. Okay, so this is opposite over radius, so this is going to be 1, and this is going to be 4. That one will do it, and this angle over here will do it. 4 and negative 1. These are both negative 1s here. Okay, so those are both my angles. This angle here, which looks to be about, that's going to be like about 200. And then this angle here, which I believe will be about 340. Okay, these are my guesses on what this is. And now I use the inverse sine function. So I'm going to, if I know that sine theta is equal to negative 1 over 4, then I know that theta is equal to the inverse sine of negative 1 over 4. This is what I can punch on my calculator to find the answer. So that's what I'm going to do now. Let's do that. So negative 1 divided by 4 equals. Okay, this is that, all right? And then I do the second function, sine inverse of the answer equals negative 14.4. Negative 14.4. Actually, my guess is not bad because I had negative 20. Negative 14.4. Isn't that annoying? But it told me here that theta is between 0 and 360. So I got some doing to do. Negative 14? Well, let's add 360 to that. Equals 345.5 degrees. And we were asked to find it to the nearest degree. So that means theta is equal to 346 or this angle over here. And I have some doing to do. That was 14.4. This is 14.4 degrees here. So if I do 14.4 degrees or 14 degrees when I round, plus 180 plus 14, that gives me 194. Remember my guess? 200. So it was pretty close. My guess is a little better there. Or theta is equal to 196. Okay, so those are my two answers for theta given this trigonometric ratio. Okay, now next section. Not bad, eh? It's just like, know what to punch on your calculator, and then you got it. Now, here we go. Each of these points lies on the terminal arm of an angle. Oh, we're very popular today, and we're getting a phone call. Give me a second here. Let's carry on. So here we are. So now we want each point lies on the terminal arm of an angle. Determine the 6 trigonometric ratios for the angle rounded to 4 decimal places. Okay, we've already done some problems like this. I'll do one more. Okay, we'll do one more. Let's take this one here because it's got clean ratios. Negative 4, 3. So you draw your axes. you go negative 4, 3. All right, it's up there. And if this is 3 and this is negative 4, this would be an angle here. This would be 3 squared plus 4 squared. Negative 4 squared, yeah, we know that that's the same as 4 squared, equals r squared. Okay, you want me to do it? Fine. 9 plus 16 equals r squared. Okay, you want me to show it? Fine. 25 equals r squared. Take square root of both sides. This is 5 is r. Okay, that's a special triangle, a 3, 4, 5 triangle. It's a trigonometric, it's a Pythagorean triple. So there we go. That's side length 5. Sine of theta. This is theta here. Sine of theta is equal to 3 over 5. Cosine of theta is equal to negative 4 over 5, adjacent over hypotenuse. Tan theta is equal to 3 over negative 4, so negative 3 over 4. Cosecant theta is equal to 5 over 3. Secant theta is equal to negative 5 over 4. And cotan theta is equal to negative 4 over 3. There, that's done. That's how you do those. So rounded to 4 decimal places. I'm not gonna make decimal places there. Okay, I'm just gonna tell you what they are. Those are exact. So who cares? Don't round it. It's exact. Determine two angles between 0 and 360 that have a secant of negative 4. Okay, so this is an interesting type of question. So let's switch to an interesting color here, and we'll make it fine. There we go. So if I know that secant theta, two angles. So secant theta has a secant of negative 4. Then another way of writing negative 4 is negative 4 over 1. All right, that would mean that its cosine, because there ain't no one wants to think about secants, is equal to negative 1 over 4. All right, now there's two places where that could be, and I think we've already talked about this exact situation in one of the other review problems. They got to get some new numbers, eh? So here, the adjacent would be 1 and the radius would be 2, and it's negative. So cosine is positive over here, so the two angles are going to be over here. This is going to be negative 1 and with a radius 4. So this point up here could be it. I can't tell you the name of that point without doing some math, so I'm not gonna. But that's a negative 1, and this is length 4. Okay? Now this one over here would be the other one. Okay? That's negative 1, that's still 4. Okay, so there's two options. This angle or this angle. All right? So now I'm going to punch this. Well, I'm not going to punch that on my calculator. I'm going to say theta is equal to the inverse cosine of negative 1 over 4. Put this in brackets in your calculator, and you will have fewer headaches. Okay, so I go inverse cosine, a wrong calculator. Hate that thing. Well, hate is a strong word. I dislike using that calculator. Inverse cosine of bracket negative 1 divided by 4 end bracket equals 104.4. Okay, so that is telling me this angle. Now I need to find the related acute angle and reflect that through this axis. Okay, so theta is equal to 104 or 104. That's the answer to this question. 180 minus 104 is the related acute angle. So that was 76. See, that's the related acute angle. Was this angle over here 76 degrees? Okay, so now if I do 180 plus 76, it gives me the other value of theta. So that would be 180 plus 76 is 200 or theta equals 256. Just 180 plus the related acute angle, the reference angle, gives me this. Okay, here are my two answers. Theta is equal to 104 or 256. Oh, I forgot to guess first. I missed a chance to do some learning. Okay, now an angle between 0 and 360 has a cosecant of negative 1. Is this enough information to determine a unique solution? Yes, it is. There's only one place where sine is -1. Okay, sine is -1 right here. So this is the angle 270. Okay? Sine's going to be negative down here and positive up here, and this is the place where it's -1. Sine is 1 at 90 degrees and -1 at 270. So this theta equals 270. Done. Okay. Now let's find our other questions here. Where are they? Oh, it's over here. Okay, so let's go over here. We'll zoom in. And now we're on to problems in 2 dimensions. Beautiful. Marco rides 10 kilometers north from his home on his mountain bike. What's that? Sync status. Oh, it's gone. Okay, that's good. All right, so we're going north on a bike from home. The fact that he's on a mountain bike doesn't change the question mathematically. He could be riding a paper airplane. He could be an ant. He reaches an abandoned railroad, turns through an angle of 120 degrees onto the railroad, and then rides another 20 kilometers. Draw the diagram, select the most appropriate trigonometric tool to determine his distance from home, and determine an exact value for his distance from home. Okay, cool. We can do all this. All right, so first we start with a diagram. I'm going to say this is north. That's helpful to remember. Okay, and before we keep going, I'm just going to pause the video and then say goodbye to my students. And we're back. So let's carry on. So here we are, problems in 2 dimensions. And if you just, it's no time has elapsed for you, so I don't need to review for you. We got north this way. He rides 10 kilometers north. That's a 10. And then he rides 20 kilometers turns through an angle of 120 degrees. So he turns not 90 degrees, but 120. He's now going this way. And he goes 20 kilometers. So that's a 20. And so this would be his home here. He's gone 20 kilometers there. And he turned 120 degrees. How much is left here? 60. Right? So this is a 60-degree angle here. So he's actually going to be behind his house. He's going to be a little further. Wait. No, this is 60 degrees here. So that's going to mean he's not anywhere above or behind his house. It actually is going to create a right angle there. It's pretty cool. So they've made it up to be that way. All right, so there's his home, H, we'll call it. He rides, and that's his final position. Okay, so this is a 10, 20. If we square that, that's 100. And we square that, that's 400. So this is going to be the square root of 300 here. You'll notice that the square root of 300, that radical could be simplified. Oh, how did I shouldn't do these things in my head and then pretend that you just know. If I square this side, we're not sure that this is a right angle yet, but this is 60 degrees here. This is 20. This is 10. I am doing a lot in my head here, aren't I? Oh my goodness. It's just funny sometimes how like second nature some of these things are, and they're not second nature yet until you've really mastered this content. So let's pretend I don't know that this is a special triangle. I'm going to start this question again. Thank you for your patience. He rides here 10 kilometers. He turns through an angle of 120 degrees and rides that way. Some amount of kilometers, 20. Okay. This is here. This is straight, so this is why do we call this turns through an angle of 120 degrees? Yeah. So it's like this would be a 90-degree turn, and then it's 30 degrees more than that. So this is 60 degrees here. Okay. And then now what I have here is I want to know this length. And if I didn't know that this was a special triangle, because I can recognize it by 1, 2, root 3, okay, and the 60-degree angle connecting them. If you don't notice that, then you're pretty much left with cosine law. You need cosine law here to find out this side length, okay? And this is what it would look like. You would call this side length, we call it A. Sure, fine, call it A. All right? And then we would say A squared equals B squared plus C squared minus 2BC cos A, where A is this angle, opposite that side. All right, so let's figure that out. Cosine of A is an exact value. We can figure that out exactly. So let's do it. A squared, and I'm telling you, this is the square root of 300 or 10 root 3. All right, A squared is equal to B squared, so we'll just call this B and this C. All right, it doesn't matter which one is which. 400, that's 20 squared, plus 100, that's 100 squared, 10 squared, minus 2 times 20 times 10 times cosine of 60 degrees. All right, now that's going to be equal to 500 minus 2 times 200 minus 400 cosine of 60. And then cosine of 60 has an exact value. What is it? There's my 60-degree triangle. Cosine is related to that and that for this triangle, so it's 1/2 times 1/2. Okay, so then this is equal to 500 minus 200 is 300, and that's A squared. So A is equal to the square root of 300, or A is equal to the square root of 100 times 3. This is a perfect square, so then we have A is equal to 10 root 3. There, an exact value for A. And if I put that on there, now we should be able to recognize that this is just this triangle here scaled up by factor 10. 2, 1, root 3. And I multiply all these values by 10 and I get this triangle. So that's how I didn't need cosine law to do this. But even if I don't notice and I just use cosine law and I don't make mistakes, I will still find it. So that is fine. So that is an exact distance from his exact expression for his distance from home, 10 root 3 kilometers. So when his mother calls and says, "Where are you?" You say, "Well, I'm 10 root 3 kilometers away from home." And cosine law, well, actually, cosine law. And I recognize that's a special triangle, Mom. So I am due west by 10 root 3 kilometers. Okay, so that's how that type of problem works. Let's do this one. Is that what's next? Let me see. Let me zoom way out. Okay, so we're going to be talking about all of these things here. Yeah, so we're going to now talk about this one. That's right. So we have triangle ABC. Angle A is 32 degrees, A is 15, and B is 18. So I like to draw these this way. I like to draw them with B up here. So this is 18. A is over there, 15. Ah, I bet this is an ambiguous sign law case. And then here, this is 32 degrees. That's A. Okay. And that's some value C. Okay, we'll call this C. This is big C. This is big A. And this is big B. All right, this is B over here. Yeah, right. And so I got everything in the right spot. Use drawing tools or geometry software to illustrate why the ambiguous case applies to this situation. Well, it's because this is less than that, and the value of, if I set it up with sine law, sine 32 over 15 multiplied by 18, if this is
Devlin, Neil, please come
less
to the
than
office.
1,
Devlin, Neil, please come to the office.
if this is less than 1, or sorry, if this is less than 1, then we have a case where we have ambiguous sign law. So do that on your calculator. 18 sine 30 over 15. 18 times sine 32 equals divide by 15. Yes, it's very much less than 1. It's a 0.635. So yes, it's less than 1. Therefore, we have a case of the ambiguous sign law. This could be this way, or it could be this way. It could be that triangle that I've drawn, or it could be with another color here, this triangle here. And this, if I bring it down, would be a right angle here. Why? Because these two triangles, it's just like this side flipped over here to the other side. They have related angles. So now sketch diagrams to represent the two possible triangles. Great, sure. So here is 18, 15, and then some value C there. Okay, that's 18, 15, 32 degrees. Okay, the other way looks like this. 18, 15, 32 degrees. A fun question might be, what's the difference in area between those two things? I don't know. It's a question you could create. All right, so solve for side C in both triangles to the nearest meter. All right, so we can do that. So let's say we need to first, to solve for C, we need to know this angle here if we're going to use sine law. We can do it this way, actually. So 18, no, it's not. This gives us this angle B. So to know this angle here, C, we're going to find this angle first. All right, it's going to be different in both cases, but they're related. All right, so I would say we already did this. This is, if I know sine 32, my unknown is an angle, so I want that on top. So I set it up just like this. Sine 32 over 15 equals sine B over 18. Okay, and then I evaluate this. I'm going to say the inverse, so that's sine inverse of 18 over 15 times sine 32. Definitely put that in brackets on your calculator. That's equal to angle B. Okay, let's move my face up there. All right, so now I punch that on my calculator. I'm going to find angle B. I already have this answer here, so I'm just going to go sine inverse equals 39.5. So I've been asked to the nearest meter. Let's keep my angle to I have 39.486. Okay, I'm satisfied rounding to 39.5. I don't think I'm going to be a meter out by using that angle. So 39.5 degrees. All right, and now, so I know this angle here, that's in this triangle, 39.5. This angle is going to be different, but it will have the same sign. It'll have the same value of sine. And just to recall, if I have a 39.5 here, then I would have the same sign over there, which would be 180 minus 39. So that would be 140.5 degrees. This is 140.5. B is equal to that, or B is equal to 140.5. Mr. Jennings, you're skipping steps again. How did you get that? Oh, well, I took 180 and I subtracted that angle because that would be the reflection of that angle through the y-axis. This is the angle that has a related acute angle of 39.5, a reference angle of 39.5. Okay, so now I know these two triangles' angles. I can use that to calculate the angle up here. And this would be 32 plus 140.5 is 172.5. So 172.5, 180 minus 172.5 leaves me 7.5 there. That's 7.5 degrees, this tiny angle. This one here is not going to be that. It's going to be something different. It's 32 plus 39.5 gives me 41.5. 41.5, 180 to subtract 41.5 gives me 139.5. This is 139.5. Okay, and you just get that by using your sum of the interior angles of a triangle. And now I can use sine law to find these unknown sides. So let's set up my two equations. And I'm going to do this one in blue. And this one I'm going to do in purple. Okay, so this one I set up, I now have a side as an unknown. So I put my sides on top. 15 over 32. Those were given. I never rounded, so I like to use those better. Equals, this is sine 15. No, sine 32. My goodness. Sine 32 degrees is equal to the unknown c over sine 139.5. Okay, so I'm going to multiply both sides by sine 139.5. In that case, oops, I just moved something. There, okay. So I'm going to multiply by sine 139.5, and then I'll get this. Sine 139.5 multiplied by 15. Don't multiply the angle, multiply the value of sine, divided by sine 32 equals C. Okay, so do that on your calculator. Cool. 139.5. Wait, clear. Sine 139.5 multiplied by 15 equals 9.74. Sounds good. Divided by sine of 32 equals 18.4. Oh, I forgot to estimate again. This is 18. This is 18.4. So this is actually really close to the same length here. Interesting. Cool. Okay, my diagram sucks. All right. So my guess is not very useful. Is that right? C is equal to. Yeah, okay, that can be true. 18.4. I'm a little weirded out by that answer, as you can tell. So I'm going to check the back of the textbook. So isn't it nice to you use your estimates to check your answers? Because you can find your mistakes. Here's my mistake here. This does not add up to 180. Remember when I doing that in my head and I'm all showing off? Well, I'm not showing off. I just think I'm saving time, but it turns out I'm not saving time. That angle is 108.5, not 139.5. So here we go. 108.5. So now I get to change this answer here to 108.5. I'll get a much bigger number here than 18. This looks like longer than 18 to me, so that's why I think this is incorrect. So let's do that on the calculator. Clear. Sine 108.5 equals, yes, so very close, times 15 equals, divide by sine 32 equals 26.8, so 27. That is the answer in the back of the textbook, equals 27. Beautiful. I thought I made a mistake way early and had to go back and look for it and find it. No. This triangle, I think this is correct. 32 plus 140.5. Yeah, that's indeed 7.5. Checking in my head, it's correct. So let's do that in, I said it would be in purple, but let's do it in blue. All right, so this one here, we can set this up with our given knowns. We want our unknown, the distance to be on top. So put this 15 over sine 32 equals C over this sine here, 7.5, sine 7.5. I'm just put that here, sine 7.5. Save us all some time, times that. Clear. Sine 7.5 times 15 equals, divided by sine 32 equals 3.7, so 4. And the textbook says 4. Oh, good, I got the right answer this time. So C equals 4. Wait, you didn't write out this line, Mr. Jennings? Yeah, I did. This over here was down there. I multiplied both sides by sine 7.5. That's how I moved that. C is 4. So this C is 4. This C is 27. Cool. Okay, that's done. Now let's go up here and we'll take a look at our last few problems here. Problems in 3 dimensions. An asymmetric pyramid has a base in the shape of a kite with the longer sides of the
Kelly,
base
Nicole, please
measuring
call the office.
150 and the shorter sides measuring 120. Okay, so kites have 2 pairs of sides that are the same lengths, and a shorter pair, 120, 120, let's say, and 150, 150. That's a kite. It's a weird shaped pyramid, eh? An asymmetric pyramid has this base. The angles between the 2 longer sides measures 70 degrees. The angle of elevation of the top of the pyramid is seen from the vertex between the longer and shorter sides is 75. Is 75 degrees. Okay, so here this angle is given, and it's 70 degrees. All right, and then this rises up. So I know that this is traveling up, 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 up to the very tippy top, and then down, 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 down. And this angle here, and this is now up in 3 dimensions, you have to imagine, is measuring 75 degrees. Okay, determine the height of the pyramid to the nearest tenth of a kilometer. Okay, tenth of a kilometer. That'd be to the nearest tenth of a kilometer. There's some weird things going on in this question. They're asking to the nearest 100 meters. Well, we could just ballpark that. I mean, that's pretty wide. It's like, to the nearest distance that I can sprint in 20 seconds. All right, so this pyramid has a face, and its face is 150 on that side and has an unknown here. So I want the distance going up to there. I also have to go pick up my daughter soon, so I may need to pause this video and continue later. All right. Some other things that we can do. We can draw these other sides. Boop. And then draw this side down here. Boop. Okay. And now I know this rises 75 degrees. So that one, do I know? No. And that one, do I know? No. So I don't know much about this triangle already. So let's draw what we know and what we don't know. So this triangle here is what I want to solve, because if I can find this height, and I know that it's the angle of elevation, so this angle here made with the ground is 75 degrees going up. So there I just need the distance between, okay, I've got it. This is much easier. I was thinking it was very, very, very hard. So what I need to imagine is this line going in between here. Okay? This line going in between here, and that's on the ground. All right, so I'm going to draw that line on the ground with a solid line. How long is that line? Half of that will make then a right angle triangle to the top of the pyramid here. And then this slant height is not given, but I don't need it, because then I'll have the distance from there to there, and then I can use tangent to find the top. Okay. I don't have to be saved by the bell and run off and pick up my daughter. I can solve this question. I now have a road to a solution. I thought that was a surface angle, not an interior angle. That's the angle that it makes rising from the side to the pinnacle. So let's draw these triangles. The first triangle that I have is an unknown side length here with 150, 150, and 70 degrees. So just draw that one. Pyom, 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 like an ice cream cone. This is my desired side. We'll call it the W for the width of this pyramid. This is 150. This is 150. And this is 70 degrees. Okay? Cosine law, because I don't have any opposite pairs of sides. So I know that W squared is equal to 150 squared plus 150 squared. So I could have just done times 2. Minus 2 times 150 times 150. So I could write 150 squared here. Isn't that neat? I can factor out a 2 150 squared, because this is 2 150 squared. So this is 1 minus, times cosine of 70 degrees. Okay, so that will give me the height of W. You can just chunk this on a calculator, but it would be much easier to say this is 2 times 150, and then to factor out 2 times 150 squared multiplied by 1 minus cosine 70 degrees. Okay? If you're confused about how I got that, just do this, okay? And just do that on your calculator. You'll find that this will give you the same thing. All right, so let's do that. So, clear. 1 minus cosine 70 equals 0.6579. I'm just going to put that in memory. I see memory recall. Mr. Jennings, you need to practice your calculator more. No one wants to see you stare at your calculator. All right, just do it. Just multiplied by brackets 2 times 150 squared in brackets. That'll do it. I don't need memory. Equals. So 29,609, and then I take the square root of that. 172. So there's 172 meters along here. So this W equals 172. So now I want this triangle here that goes, I'm just going to put another point on here, call this the point M. I'm going to call this the point S for side, and I'll draw you a new triangle. M is the middle, has a right angle. Here is S for side. We know this angle is 75 degrees. That was given. And we know this distance, S to M, is a half of this. So that would be divide by 2 equals 86. So we can use that to find the height of this pyramid here. So now what relationship relates those? This is the opposite. This is the adjacent. So tangent. Tan 75 degrees equals the opposite over 86. So I'm going to do 86 times tan 75 times tan of 75 equals 321 meters. To the nearest tenth of a kilometer, well, 300. We lose quite a lot of detail when we round to the nearest 100 meters. So O is the opposite, or I should have said H for height. Let's just use H, okay? H for height. Height is equal to 321. So H is approximately equal to, they would like 300. Therefore, the pyramid is 300 meters high. And that should be like a reasonable answer. We didn't get an answer like 70,000, and we didn't get an answer like 2. It's not 2-meter high pyramid. We don't call that a pyramid. It's not even a speed bump. So anyway, so yeah, there's that. That's that question. And then we check our answer in the back of the book because it's right here. 321 meters. So they said round it to the nearest tenth of a kilometer. That's a typo. They meant meters, and that would be a reasonable thing to round to, but I rounded to the nearest tenth of a kilometer because I follow instructions. Okay, so I should probably go get my daughter, but here, Kate is sailing her boat off the coast, which runs straight north and south. Her GPS confirms blah, 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 blah. I'm going to answer this one later. Okay, so I'm going to cut this video here, and I'm going to upload another one later with this question and the first question from our practice questions today, which is this one down here, all right? With the 2 cars that leave on different roads, and we have to use speeds and things and blah, 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 blah. All right, so all of that is coming to you later tonight. This one is review part 1. So thank you for sticking around, and you'll see this video soon, and you'll see the other video by 8 o'clock tonight, I expect. Bye for now, everybody.